I am S. Ajit Kumar. I am doing my Bachelor Engineering degree in Welded High-Tech. My project title is Experimental Investigation of Polypropylene Fiber in Fly Ash-Based Concrete. My project mates are D. Madan, M. Kamesh, P. Saravanan. We are doing our project under the guidance of Mr. Ayyappan, ME, Assistant Professor of Welded High-Tech Engineering College. Our project aim is to determine the compression and tensile strength parameters and to find the behavior of polypropylene fiber in concrete, to find the exact max proportion which gives maximum strength, and to reduce the cracking formation on concrete. Our project objective: to reduce the fly ash, to increase the concrete property by using fiber, and to reduce the environmental effect. Introduction: while burning of coal it produces fly ash and it will be in bulk amount. Due to its fineness, it will be used as a bonding agent in construction unit. It will be reduce the waste and used to keep environmental friendly. By using fiber, provide structural strength to concrete. The polypropylene fiber is used to improve the strength. Fly ash. Fly ash generally refers to as produced during combustion of coal. Fly ash includes substantial amount of silicon dioxide and calcium oxide. Fly ash is classified into two types, F-type and C-type. F fly ash contains less than 20% of calcium oxide and C fly ash contains more than 20% of calcium oxide. Fiber. For our project, we used monofilament polypropylene fiber. Polypropylene fiber are made from propylene gas derived from petroleum byproducts. Every year, 4 million tons of polypropylene product produced. For our project, we may refer some literature and journals. By this, we may conclude that fly ash percentage increase compressed strength and split strength decreases. It will produce green concrete for construction, and polypropylene is easy to place and compact and finish and pump. Polypropylene fiber reinforced concrete shows improved impact resistance and the possibility of increased tensile strength. These are concluded by referring the journals. This is our methodology. First we collecting for data for our project, and then collecting raw material, then testing on raw material, then we prepare mix design and the casting of cube and cylinder, then going to test for the cube and cylinder, then the result is plotted. Our mix proportion is, we first prepare ordinary concrete mortar and then replaced by cement by its weight as fly ash. The fly ash replaced 20% and 25% and 30%. By replacing fly ash, we may add 0.4% propylene fiber. Test to be conducted: compression test and direct split tensile test are to be conducted. Collection of material: for our project, we may collect cement, coarse aggregate, fine aggregate, fly ash, propylene, and water. By conducting test, we plotted the property of cement. The specific gravity of cement is 3.15 and the finest 95%. Initial setting time is 30 minutes. The property of fine aggregate: properties: specific gravity 2.4, fineness 2.7, and sieve size 4.75 mm, and density 1614.814 kg per meter cube. Property of coarse aggregate: density 1531.9 kg per meter cube, specific gravity 2.6 and fineness modulus 7.2. Property of fly ash: specific gravity 2.4 and fineness 320 kg per meter cube. Chemical and physical property of monofilament polypropylene fiber: tensile strength is 0.76 kg per centimeter and dosage is 0.25 to 0.45%, melting point 162 degrees Celsius and ignition point 593 degrees Celsius. The thermal conductivity is low for polypropylene. This is our mixed design. Our target strength is 38.25 Newton per mm square. We take water cement ratio as 0.4 and our slump value is 75 to 100 mm, so there is no record for addition of water. by calculate by referring IS 102062, we may design our project, and our proportion is 1 is to 1.2 is to 2.42. Ordinary concrete casting. For ordinary concrete casting, for a single cube, the material required are given below. The amount of cement required for a single cube 1.61 kg, and coarse aggregate required is 4.13 kg, and the fine aggregate required is 2.32 kg. For a single cube, the water required is 0.650 liter. Ordinary concrete casting for cylinder. Amount of cement required is 2.51 kg, and amount of coarse aggregate required is 6.49 kg, and amount of fine aggregate required is 3.53 kg, and water required is 1 liter. In that, we partially replacement of fly ash 20% by weight of cement. For tube cube casting, the amount of fly ash required 0.970 kg, and amount of cement required 3.880, and amount of coarse aggregate 12.39 kg, and amount of fine aggregate 6.70 kg. Water aggregate is 2 liter, and amount of propylene is 20 gram. For cylinder, the cement aggregate is 2 kg, and the fly ash is 5 kg added by replacing the cement, and the amount of coarse aggregate is 6.5 kg, and the amount of fine aggregate is 3.5 kg. Water aggregate is 1 liter, and the amount of propylene is 6.5 gram. Partial replacement of fly ash by 30% by weight of cement. For 3 cube casting, amount of fly ash required is 1.5 kg, and amount of cement required is 3.4 kg, and amount of coarse aggregate required is 12.39 kg, and fine aggregate required is 6.7 kg. The water required is 2 liter, and the amount of propylene added is 20 gram. Amount of for casting a cylinder, the amount of cement required is 1.75 kg, and the amount of fly ash required is 0.75 kg, and the amount of coarse aggregate is 6.5 kg, and the amount of fine aggregate required is 3.53, and water required is 1 liter, and the amount of polypropylene added is 6.5 gram. Partial replacement of fly ash 25%. For 3D casting, amount of fly ash required 1 kg, and amount of cement required 3 kg, amount of coarse aggregate required 12.39 kg, and amount of fine aggregate required 6.7 kg. Water required is 2 liter, and amount of propane gas 20 gram required. For cylinder, amount of cement required 1.875 kg, and amount of fly ash required 0.625 kg, and amount of coarse aggregate required is 6.490 kg, amount of fine aggregate required 3.53 gram, and the water required is 1 liter, and the amount of propylene gas 6.5 gram. These are the pictures taken during our project. By conducting test, we may get the result. Compression strength test result is shown here. While replacing of cement by 20%, it will give maximum compression strength, that is 38.5 Newton per mm square. After that, beyond that, the 20%, the strength is going to decrease. The graph shown at 20% fly ash replaced gives the maximum compression strength. By conducting tensile strength test for cylinder, we may get the average tensile strength. At 20%, fly ash replaced by weight of cement gives the maximum tensile strength, that is 3.2 Newton per mm square. Beyond that, the strength is going to decrease, which is compared while comparing to conventional concrete. The 20% replaced fly ash gives more tensile strength. Our graph shows that the 20% fly ash with fiber gives the maximum compression strength. Result and conclusion. The 20% fly ash replaced concrete gives maximum compression strength of 38.5 Newton per mm with fiber, and 20% fly ash replaced concrete gives maximum tensile strength 3.2 Newton per mm square with fiber. Out of various proportion under the motor mix containing 1:1.2:2.4 with polypropylene fiber and fly ash replaced use. This method is found to be economical and cost saving are ascertained with cement with fly ash motor when compared with normal motor. By fly ash saves 20% cement. Thank you.